Hello everyone. So this is Xiaoli. Today, Wenchen and I will give a talk about what's new in the Spark 2.3. So both Wenchen and I are software engineers and DataWorks. So we are also the Spark committer and the PMC members. So DataWorks is funded by the original team who created Apache Spark. And our mission is just to simplify the big data and AI problem. It is powered by Spark. It is available in both Azure and AWS. Using the notebook, you can explore the data, train, and serve your model, run and debug your Spark applications. So Spark 2.3 is our most recent release. And this release has many cool and important features. It adds support for continuous processing in schedule streaming and a brand new Kubernetes scheduler backend. And the other major updates includes like new data source schedule streaming API version 2, and many performance enhancements in PySpark, Spark SQL, ORC reader, and so on. In addition, this release continues to focus on the stability and usability, and it resolved 1,399 tickets. So let's start the work we did in the streaming side. So structured streaming was introduced in Spark 2.0 and designed to support end-to-end real-time applications and that combines streaming with a batch and interactive analysis. In DataWorks, structured streaming is 10 times more usage than the original Spark streaming, DStream. And it has already processed more than 100 trillion records in the production system. This year, there's a 6-more paper called Structured Streaming, a tutorial API for real-time application in Apache Spark. So if you're interested in this, please download and read it. So there's many cool ideas and explain a lot of details why we designed that. Structured streaming achieved high performance using the Spark SQL's code generation engine and outperforms Apache Flink by 4 times and the Kafka Stream by 90 times. Structured streaming provide purely declarative APIs based on the automatically incrementalizing a static relational query. You can specify that in SQL, data frame, dataset APIs. That makes it accessible to non-expert users. Structured streaming is designed to support end-to-end real-time applications that combine the streaming with batch and interactive analysis. So in Spark 2.0, structured streaming was introduced with micro-batch execution engines. So each micro-batch interval normally set to like a few hundred milliseconds or a few seconds. So it executes as a traditional Spark job composed of a DAG of a task. In this release, we introduced a new continuous processing mode. Continuous execution is similar to a much larger number of triggers, and it uses traditional long-running operators to provide low latency, and at the cost of more static scheduling. Continuous processing enables low latency, like 1 millisecond, and at least once for tolerance. But if you use micro batch processing, it can achieve exactly 1 guarantee, but the latency is around 100 milliseconds at best. So you can see this is a overall picture. Declarative API of structured streaming is not tied to the execution strategy. So that is the beauty of the declarative API. User can easily switch between the different execution engines. Let's see the example. So this is just a show. So in this example, you read stream and then write stream back. So the only difference To use a new continuous processing mode, you just need to change that line. You can switch from the execution micro batch to continuous processing. For more details, you can read this blog, and it shows what we did and what we are trying to do. And also, it shares a notebook. You can play with it. In Spark 2.3, the supported operations are map-like dataset operations, including like projection, selection. Selection is like filters. And all SQL functions we support, except the current timestamp, the current date, and the aggregation function. But we plan to support that in the next release, in the future releases. And the Kafka is also supported in both source and the sinks. And the other supported like RAID, memory, console things, majorly for the debugging. So another important feature in the streaming side is stream join. So this figure shows a typical use case. It's ads monetization. Basically, what happens is we need to do two joins. One is from the ad impression. Another is user clicks. So we join them together and then get the results. For more details about the stream join, you can read this blog and to understand what happened their side. Okay, so in this release, we also have two major features in MLlib side. So one is to deploy the MLlib on the structured streaming. Another is to read the image to different. So let's talk about this. So model transformation and prediction can be applied on both batch and streaming data with a unified API. And after filtering a model or pipeline, you can deploy it in a streaming job. So this is just a very simple example how to do it. Very clean, very simple, right? So there's a notebook you can try. So we also have a talk last week, 2 weeks ago, about how to deploy MLlib for scoring the structured streaming. You can watch the video in the YouTube. Another feature is the image reader. So Spark is being used more and more in the industry. And some new use cases are emerging for different data formats beyond the traditional SQL types. Deep learning application commonly deal with the image processing, but there's no standard way to represent the image in different. So this release adds a native support for representing images in the Spark different. And this facilitates the integration with deep learning frameworks. So it's also a very simple API to create the image data frame. Okay, so let's talk about what we did in PySpark. So PySpark was introduced in the Spark 0.7 and became the first-class citizen in the data frame API in the Spark 1.3, so 3 years ago. The data frame API is available in the Scala, Python, Java, and R. Python is currently the most popular one. We are seeing more and more users to run Spark on a single machine, often on their laptops, to process small to large data sets, and instead of using the large cluster of machines. We also observe Spark offers a faster runtime and greater scalabilities than the PyData tooling like Pandas. So Spark can often be faster due to parallelism, and in the single node machine. And Spark can have a lower memory consumption and can process more data than laptop's memory size. And because it does not need to load the entire data set into the memory before processing, Spark has a better pipeline execution engine. So you can see here the test case we show is a Pandas crash because of out of memory, but we still can continue process, and the performance we are much better. So for more details, you can read how we benchmark the Apache Spark on a single node machine. You can download and try it in your machine. But at the same time, we also observe PySpark UDF is much slower than the Scala and the Java UDFs. It is majorly because of actual serialization and the Python interpreter. So in this release, we avoid unnecessary data serialization and speed up the execution by using the Apache Arrow. Currently, this is being used when you convert the data frame from and to pandas data frame. And Spark. So in this release, we also introduced a new UDF called pandas UDF. So pandas UDF is executed in vectorization. So that means Spark will execute pandas UDF by splitting the columns into multiple batch and call the function for each batch as a subset of the data. And then you will combine the results and return the combined results. So currently in this release, we offer like Scala pandas UDF and the group map pandas UDF. You can read the document and know what happened, how to use it. And you can see the performance difference is huge, more than 200 times faster. For details, you can read this blog. Also, there's a notebook you can play. So then let's talk about another cool feature in the Spark 2.3, deploying the Spark application natively on the Kubernetes. So based on the Google trends, in the past few years, Kubernetes is growing very quickly. So we are seeing more and more demands from the community to run Spark natively on Kubernetes. You can see this year, Kubernetes already, exists more than Hadoop. So since 2016, the Kubernetes community already started a proposal for running Spark applications natively in Kubernetes. So a native Spark application in Kubernetes is simply a custom controller which can create like Kubernetes resources in response to requests made by the Spark scheduler. And starting this release, users can launch Spark workloads into an existing Kubernetes cluster and take advantage of Spark ability to manage the distributed data processing task. And the Spark workloads can make directly use a Kubernetes cluster for multi-tenancy and sharing through the namespace, quarters, and best of all, it requires no change of the new installation on your Kubernetes clusters. So that means you just create a Docker image and set up the right RBAC roles for your Spark application, and you're all set. So in this release 2.3, we support the Kubernetes 1.6 and up, and support like cluster mode, static resource allocation, Java and Scala application, and so on. So more features are coming in the next releases. So please try it. Open the JIRA if you have any like requirements, hit the bars. Yeah, feel free to do it. So basically, I finished the first 5 features, major features, and my colleague Wenchen will continue the talk and give another 5 features. Thank you.
Hello everyone, I'm Wenchen. So Xiao has covered some new features in streaming, in machine learning, in PySpark, and in the resource manager. And from now on, I will take over and share with you more features about the performance and stability and usability improvements in the new release in Apache Spark 2.3. So the first thing I want to mention is the history server v2. So here is a little about the background about the history server. So when you launch Spark applications, the application will generate logs about all the events happening in the Spark application with JSON format. And the history server will read and analyze these logs and present the Spark runtime metrics on web pages, so you can track what's going on your application post hoc. So that's why we call it history. However, the history server has two problems. So first, it's stateless, which means if something happened, like you crash your server and you relaunch it, it has to read the event logs again and pass them again, which is very costly because it's JSON format. And the other problem is it has to keep all the data, the UI data in memory, which is not scalable. For example, if you have a lot of applications running and you have each application has a lot of jobs and each job has a lot of tasks, so then you have a lot of UI data in memory and which will crash your server. So in Spark 2.3, we redesigned the history server and use a keystone to store the UI data. So this brings two benefits. So first, it becomes stateful. So the keystone is persistent, and which means your UI data is also persistent. So if something happened to your server and it crashed, and when you relaunch it, it can still just read the data in the keystone instead of read the event log again in JSON format, which is too slow. And the other is it's scalable. Because the keystone is persistent, and it doesn't need to keep all the data in memory. It has AI cache to only keep the whole data in memory and can spill other data in disk. So which means you can use this server to serve a lot of applications in a big cluster. The other one I want to mention about is a new DataWorks API in the Spark 2.3. So since before, so we need to understand what's the problem in the previous interface. So first thing is that the V1 API, it leaks the upper level API in the DataWorks. So for example, RDD and SQL context. This actually brings many problems in reality. So for example, since Spark 2.0, we want encourage users to use data frame over RDDs. And we also introduce a new entry point, Spark Station, to replace the SQL context. However, because of these two APIs are still used in the DataWorks API, which is marked as stable, so it's kind of becomes a trouble for us. And the second thing is the V1 API is very hard to extend. So for example, if we want support kernel scan, so for example, if you have a DataWorks that is in a kernel format, you want to use kernel scan to make it run faster. And this is not, it's impossible to do in the V1 API. Or for example, you want to push down more operators like limit, like aggregate. And so if your DataWorks can run faster, it's also hard to do with V1 API. And the next thing is about the write API. So for write, one thing you want to keep in mind is transaction. How you can avoid writing partial data or dirty data. So the V1 API has nothing about this. So you don't know how to correctly implement your data to write your data transactionally. And this can be solved in the next API. And also, the V1 API is batch only. So from Spark 2.0, we reinvent the streaming and streaming, and which means streaming becomes a very important part of Spark. And maybe one day you want extend your data to support streaming, and then it's hard because the streaming is a entirely different set of APIs you have to learn and try. So in Spark 2.3, we have an experiment release of a new API for DataWorks, the V2 API. So this is we fix all the problems we meet in V1, and we learn and move forward. So first of all, it supports kernel scan, and also it has a very flexible push down framework, so that if we have something new we want to push down to DataWorks, it's easy to extend it in future releases. And also, now we allow the DataWorks to report some basic status like your size, your name, your row counts, or some others. And also, we allow you to report your partitioning. So for example, if your data is kind of hash partitioned, which is basically popular in like Cassandra or other systems, so you can report this, and Spark can leverage this and to better plan your queries. For example, you can avoid shuffles at the Spark side because the data is already partitioned in the correct way. And also, the V2 API has redesigned the write API that it's fully transactional, so you can know how to implement your data in a transactional way and avoid the data loss or data corruption stuff. And also, the V2 API is designed to unify the batch and the streaming in one framework. So one day, if we want to extend your data, it just you want to learn some extension point to add a streaming support in your data source, which is better than the V1 API. OK, the next stuff I want to talk about is the UDF enhancement. So this is very likely that users want to have some custom protein logic that is not offered by Spark building functions, and they have to write UDFs to express their logic. However, the UDF sometimes is hard to use. So in Spark 2.3, we made a lot of effort to improve the usability of UDFs. So for example, we make it easier to address Java UDFs, and we also support creating the UDF functions for the upgrade. And also, there's one important thing is we allow users to declare if its UDF is deterministic or not. This is kind of a very important property of a UDF. So for example, if you have a function which is returns some random value, and you will want the Spark to respect it and to not optimize in a wrong way, which will give you some unexpected result. So in Spark 2.3, you can use this API to mark your UDF as non-deterministic. And then Spark will respect it and will prevent to wrongly optimize your UDF and give you the expected result. And also, we have made some efforts to improve the Java UDF. So before that, if you're using PySpark, you have to write your UDF in Python, which is, as Xiao mentioned, is pretty slow. And although in 2.3 you have the neutral pandas UDF, however, but we still want kind of integrate the Java UDF into PySpark. So here in Spark 2.3, we gave a new API that allow PySpark users to register Java UDF by the class name into your Python programs. So this is a pretty good feature. So for example, if in a company, you can have two teams. One team is focusing on developing the UDFs in Java, and the other team can just write Python programs to launch protein jobs in Spark. The other thing I want to talk about is the code review improvements. It's still about stability. So in Spark SQL, we will compile the entire query plan into a Java code and run the Java code on all the executors on the Spark cluster. So, however, it's a very fast way to execute your queries. However, it has some problems. So if your query is very complex, and Spark SQL will generate very large amount of Java code to run it, and this may hit the JVM limitations. So for example, JVM has a limitation about the 64 KB method size, and also compiler has a limit for the constant pool. So in Spark 2.3, we improve the code a lot to make it much smarter, and it can scale if the code is too big. For example, we can spill the code into a new method, a new class, to avoid the limitation of the JVM. And also, we made some changes in the wholesale code regime. So we can we provide a config to allow you to tune the size of your wholesale code regime size, which can avoid some other limitation about performance. So for example, in JVM, if your method is over 8K, it will prevent to jet it, and which makes your performance worse. And you can use this config to tune it. The other thing I want to talk about is the native OS support. So in Spark, we have built-in OS support, which means you can just read the OS files with Spark without any packages. This function is actually provided by Hive. Spark actually depends on some Hive libraries, Hive 30 encoders, and we use the Hive library to read the ORC files. So, however, this is not an ideal way because now we are bound with Hive, and also some new features in ORC may not be in the Hive version. So in Spark 2.3, we introduced a native ORC reader. So which is it has no dependency on Hive. It is purely an independent project, and after shift to the OS reader, we can gain better performance and less dependencies. And also, this new reader comes up with a vector reader. So after the vector OS reader, the performance of ORC and packet becomes comparable. And before Spark 2.3, Packet is much faster because Packet has a kernel reader, and now the ORC also has one. For safety reasons, so this new native ORC reader is turned off by default in Spark 2.3. So if we want to try it, please change this config to turn on the native reader. And in the next release, we have also already turned on this native reader by default. OK, last but not least, I also want to introduce some other various SQL features in Spark 2.3. So first, we have many performance improvements in the Spark SQL side. The first is the CBO. So previously, the CBO assumes your data is evenly distributed, which is kind of mostly wrong for real-world data. So in Spark 2.3, we added histogram support, which has a better estimation about your data distribution, and also it makes Spark to have a more precise estimation of your statistics, like your size, like your load counts. And also, we have many enhancements in the rule-based optimizer and planners. And also, other features like better support for the partition predictive pushdown and other stuff. For the API, we also have many efforts to make the API easier to use. So for example, we changed the Spark SQL parser and analyzer to make it more anti-SQL compliant. And also, we improve the data frame dataset APIs to make it easier to use. And also, we add a bunch of built-in functions so that you don't need to write UDF all the time. And also, we provide better Hive capability to make Spark work with Hive better. So to summarize today's talk, we covered some new features in the streaming, machine learning, PySpark, and Kubernetes. And also, we covered some performance, stability, and usability improvements in Spark. So, and our Spark 2.3, there are still many projects that is ongoing. And also, I want to share with you here about some of these exciting projects. So, first, a disclosure. So this is not a full list because there are so many things in the next release, and I don't have enough space to put all of them here. So this is just some of them. And if you are interested, please keep an eye on the next Spark release. So first thing I want to talk about is the higher order functions. So in Spark, it's usually hard to deal with kind of the array type values. So for example, if you have an array, if you have an array in Java or Scala, you can use a loop or some map function, field function to transform it, to process it. But in Spark, it's hard to do. So with the higher order functions, it's much easier to deal with it. You can use transform, just like the Scala map stuff, to change the array values. And also, we have some value convenience functions to update your array columns. The next one is a very big performance improvement project is adaptive query planning. So this is based on the fact that Spark uses shuffle as a boundary. So shuffle will stop your query in a point, and the next plan can only be run after the shuffle is finished. This gives Spark a chance to look at the data before we move forward. So in this project, we will dynamically plan the query and after the shuffle. So if we can see the real data in the shuffle and decide what's the better query plan next. So for example, if we plan to use a shuffle join, and after shuffle we found that, hey, this table is very small, we can switch to broadcast join to make a query run faster. The other thing is deep learning. So deep learning is very hot currently. So Spark also want to have a deep integration with the deep learning frameworks. So in the next release, we want to introduce a very deep integration. So we will change the Spark code to support that. So for example, we will introduce a new schedule model, the GAN scheduling, and also a barrier sync function to make for the deep learning tasks. And also, we will provide a fast data framework to exchange data between Spark and the frameworks like TensorFlow. And also, we port the machine learning pipeline to Spark R, which means you can also use the fancy APIs in your R language. And also, we have a bunch of build improvements that is going on. So we want to support Scala 2.12 and Java 9 and Hadoop 3.0. in the next release, we also want to improve some existing features. So for example, Xiao mentioned how good is the new pandas UDF is, and we keep improving it in the next release. So we will support in the function with the pandas UDF, and we also will support the partial upgrade for better performance. And also the KDS integration, we will also add a bunch of new features. So for example, you can, in the next release, you can launch your PySpark jobs with Kubernetes. And also the Spark Java can dynamically allocate and release the Kubernetes pods. And also we can launch external Java service in Kubernetes. We also, this is also mentioned by Xiao before, so we will also add Java support to the continuous processing mode, which means you can run join, upgrade with the continuous mode in the streaming. And also we have a bunch of improvements for the new DataWorks API. So we want to integrate with catalog, which means you can read the table metadata from a different place. And also we want to support more operator pushdown. That's today's talk. Thank you, and I'm very happy to answer any questions.
Yeah, please.
So Spark on Kubernetes. So obviously, right now it is experimental.
Yeah, still experimental.
Talk about exactly what the issues are currently and when it's expected to be ready for production.
So for example, the PySpark is not supported, right? So there are many different limitations. So now, please try it. And if you hit any limitation, just let us know. We want to solve it as soon as possible. So yeah, currently there are some limits. So in the dev list, we send out some like a roadmap. So to resolve these issues. So you can. Maybe 3.0 it will be GA. 2.4 maybe the next release of 2.4 should be the 3.0. Yeah. Thank you. Yeah.
Yeah. So I saw you mentioned in 2.3 a lot of improvements in the ANSYS SQL compliance. Can you introduce a bit on this? So what's the area?
We forgot the exact JIRAs, but we did a lot of and we also plan to improve that. There's no umbrella JIRA, unfortunately.
Yes, yeah, something like
So
type cohesion, something like the syntax support, or I mean, kind of make the syntax more flexible. Other stuff, I can't remember all of them, but I think we can have I think there's a list of JIRA. I'm not sure.
Yeah, we didn't create.
I think in the release notes we have all of them. So
Yeah.
in the release notes, we covered all of them in the release notes.
Yeah, please check the release notes. Okay, thank you.
Hello.
Was the 2.3 the enhancement for the ORC, native support for ORC? Now is it the same speed, or which one is the preferred format? I mean,
It depends on you, right?
It depends on your workload.
at same level now?
Yeah, same level now. So
Almost same.
we have a benchmark. So
Yeah.
so it's
So
it
that
depends on
totally
case.
depends on your workload, right?
Yeah. So whenever you have many filters and some other stuff, so there are many details in the format. So for example, the pretty pushdown and other stuff. So it depends on the query. But we can see that for full scan, they have the kind of very similar performance.
So what was the main difference between the pros and cons? Just briefly.
In Spark side, no difference. But in the ORC implementation and the Parquet implementation, they are different, right? They use a totally different format.
On the Spark side.
Yeah. So no any difference now. But like what Vincent just mentioned is like the nested schema. Oh, you did not mention, but So in the next release, we also plan to support a nested schema pruning. For Parquet, we only support Parquet. And the ORC, we don't think we have a plan to support nested schema pruning. Push down, I mean. You mean image reader or?
Currently, there is a Spark DL by DataWorks, that library.
Oh, different library. So so far we don't plan to, integrate that into the Spark upstream. So that will be still a separate library. Yeah.
And is there a plan to add more algorithms to Spark ML?
Oh, yeah. So recently, yeah, we are working on that also. So there's a multiple key contributor, and they are working on the enhancement in MLlib. You will see more activity, more PRs.
Meaning more data scientists use Spark
Yeah,
in doing their laptops.
yeah. Thank you.
So you talked about MLlib, right? Not ML.
Oh, no, MLlib.
But MLlib is only in maintenance state.
I think MLlib is the new one. So based
Yeah.
on the data frame.
Yeah.
Yeah. So basically, what happens is we Spark MLlib, right? So
Oh, do you mean the package name, not the project name?
yeah.
Okay,
Sorry.
the package name, yes. I think.
Yeah. So what happens is we believe in the future, like GraphRam, MLlib, like structured streaming and Spark SQL, all of them will be powered by our optimization, Spark Optimizer, and Spark SQL compilers, and yeah. So that's why
So
we
I don't think I got answer to my question. That you mentioned about MLlib.
yeah.
Is that the MLlib package, or you are also including .ml inside that? Because MLlib, as I understand, is it's only in maintenance mode. Nothing new is happening.
Oh, you mean, okay.
So
Is it .ml?
So it's,
yeah. I think
I don't remember which one is the new package,
Yeah.
but we, new package use definitely as the API.
yeah.
Yeah, that's, I think we are mentioning.
So in this release, in the 2.4 release, we try to move all of them to the DataFrame API. Yeah, not RDD API. Yeah. So this is the plan.
So at least the API now is used DevLin, but the implementation may still use RDD, and we are trying to move forward to DevLin.
Yeah.
But I think the difference was something else. The MLlib had the algorithms of Mahout, but ML
Oh,
algorithms of
yeah. So there's some functionality gap. Some of them have
Oh.
not moved from ML to ML.
Okay.
Yeah. Maybe you can create some JIRA and add some key committer like Xiangrui. Yanbo maybe. Yeah. Xiangrui or Yanbo. So yeah, and Joseph. Yeah. So they are very active in ML now. Yeah.
In the continuous streaming, I have a question. What are we using for distributed checkpointing and state store?
Yeah, I think we use, so in streaming, we have a concept called epoch. So even your data is streaming, but we still need an epoch to checkpoint your data. So in the new continuous mode, we still have this concept epoch. So even if you just process the data one by one, and at each epoch, you will do a checkpoint to write a log. And remember what's the offset of your data now. And so if that fails, we can restart at this certain offset.
Right. So that's the stamping part of the barriers and what we know as barriers in Flink.
Yeah, so for now, because we are just map only, no shuffle, so it's a very simple model to implement this checkpoint.
So how do you store the state in a distributed way?
Oh, it's so each task, each task, streaming task, will so it by a certain interval, so we call epoch, it will report the offset to driver side, and the driver side will collect all the offsets from the tasks and write these offsets to a log in HDFS or some other file systems.
One generic question.
Okay.
Is it a good practice to run rules against the Spark stream data?
Glue?
Glue, right?
Roots, sorry, not rules, some kind of rules on the data.
What is roots?
No, it just, we have, I want to run some rules on the data
Okay.
that's streaming to the Spark. Is it a good practice?
Rules.
Oh, do you mean, oh, rules? So,
I would say.
So you want to add some rules to the
Business rules.
oh,
business
rules.
rules.
Yeah, I think,
Is it a good practice, to run the business rules on the stream data?
yeah,
I think
it's
so.
kind of, we call it
Yeah.
streaming ETL or something you can.
What's a good rule engine you will recommend to run the rules?
Well, that depends on how you implement your rules. So it's all business logic.
So time is up. So maybe, yeah, we can
talk offline.
discuss offline.